Right. So as mentioned previously, the slope of a line is the ratio of the vertical change to the horizontal change between any selected points on the line. We can formalize this principle diagrammatically as follows. And once again, it's totally inconsequential which 2 points on the line are selected. It also doesn't matter which point you label x sub 1, y sub 1, x sub 2, y sub 2. And we use the Greek letter delta to represent the notion and phrase change in. So we want to come up with a concise definition, namely, if x sub 1 does not equal x sub 2, the slope of the line through the distinct points x1, y1 and x2, y2 may be computed as delta y over delta x, which again is the change in y over the change in x. So let's talk about magnitudes in the context of linear slope. And we're not particularly concerned here with numerical values of possible constants, which may define slope, but rather we're concerned with their charge, to borrow a term from physics. Meaning, does the line have a positive slope? Does it have a zero slope, or no slope? Or does the line have a negative slope? And so as seen above, a dextrolinear rise has a positive slope, a line that neither rises nor falls bidirectionally has zero slope, and a level linear rise, or dextrolinear fall, has negative slope. Moreover, the slope of any vertical line does not exist, which is distinct from a zero slope, of course. Okay, let's talk about parallel lines. So two lines L sub 1 and L sub 2 in the same Euclidean plane are parallel if they never intersect, neither locally nor in the extreme. For two lines not to intersect, they must rise or fall at the same rate, which is to say their slopes must be the same. Two lines are parallel if their slopes are equivalent, and two lines with equivalent slopes are parallel lines. Once again, we can formulate this idea more rigorously using expressions drawn from symbolic logic in the following manner. And so all we've done here is taken the semantic content of the paragraph above and stripped it down to its bare bones. Let's have another sketch to see what this looks like in the coordinate system. Perfect. Okay. Two lines that cross at right angles are said to be perpendicular lines. Two lines will be perpendicular to one another when their slopes are negative reciprocals. For any slope a, its negative reciprocal is minus 1 over a. Let's have another sketch of perpendicular lines in the coordinate system. Finally, let's tabulate some numerical data so as to build some intuition for the arithmetic composition of reciprocals. Perfect. And we're done.